Welcome to homework.
So here in this problem we have to find the minimum entropy change of the heat supplying source, and 100 kilojoule of work is done on the water that is being heated. So work is given as 100 kilojoule and rest data is same as that in the problem number 7.54. Because work does not involve any entropy change, so the answer will also remain the same as that we did in the question number 54. So let's proceed with the solution now. Rigid steam cooker whose volume is 20 liter, and it is given when the pressure reaches to 150 kilopascal, the pressure relief valve opens up, and initially the water is filled at 175 kilopascal. So P1 is 175 kilopascal and the quality is 10 percentage, or we can write 0.1. Quality means the dryness fraction of water, and now heat is added until the quality becomes 40 percentage. So x2 here is 40 percentage, and that is 0.4, and the final pressure becomes 150 kilopascal, and we have to calculate the entropy change, the minimum entropy change. So for that we'll be using the table A5 to get the required input data. So initially P1 is 175 kilopascal and x1 is 0.1. So at this point we'll be calculating the specific entropy and specific volume, that is V1 and S1. But to calculate this we should know Vf and Vfg. So because we know that V1 is equals to Vf plus x times Vfg, and S1 will be Sf plus x times, this is x1, x1 times Sfg. Now we'll be using the table A5 to obtain this value Vf and Vg. Vfg corresponding to this pressure 175 kilopascal. So Vf from the table will be 0.001057 plus 0.10 times Vfg. We know it is Vg minus Vf, so Vg will be from the table will be 1.0037 minus 0.001057, and the unit is meter cube over kg, and here also the unit is meter cube over kg and this plus sign. So after solving this we'll get the value of V1 as nearly 0.1013 meter cube over kg. Now next we'll be calculating the value of SF. This S1. So SF corresponding to this pressure will be 1.4850 kilojoule over kg Kelvin, plus x1 we have 0.1 times SFG is 5.6865. So after solving this we'll get the value of S1 as 2.0537 kilojoule over kg Kelvin. So we have calculated S1 and V1. Now next we will be calculating the value of S2 and V2 by following the same procedure. So P2 is 150 kilopascal and x2 is 0.4. So again V2 will be equals to Vf plus x2 times Vfg, and S2 will be equals to Sf plus x2 times Sfg. So again by using the same table we'll be obtaining the value of Vf and Vfg from the table A5. So Vf from this table will be 0.001053 plus x2 here is 0.4 times Vfg is Vg minus Vf, so Vg is 1.1594 minus 0.001053. So it will be equals to, that is, this is V2. V2 will be equals to nearly 0.4644 meter cube over kg. Now next we'll be calculating the value of S2. So for that, SF corresponding to this pressure will be 1.4337 plus X2 is 0.4 times SFG will be 5.7894. So after solving this, we'll get the value of S2 as approximately 3.7494 kilojoule over kg Kelvin. Now in the question it is given that only water vapor escapes through the pressure relief valve. So we'll be using the conservation of mass principle to calculate the rate of mass removed from the cooker with respect to time. So we know that dm of the control volume divided by dt, that is the rate of change of mass, will be equals to sigma mass in minus sigma m dot out, and that is equals to, since it is given that since in the question there is no mass input, so this will be 0, so it will be equals to minus m dot out, or we can write that sigma m dot out. So we can write that dm by dt will be equals to minus m dot out. Now next we will be using the entropy balance to calculate the entropy. So according to the entropy balance, we can write that ds of surrounding by dt plus dms divided by dt plus m dot out times entropy is greater than or equals to 0. And m dot out we have obtained as dm by dt, so we can write this expression as d of the surrounding, ds of surrounding divided by dt plus this is dms by dt minus this will be s times m dot out is dm by dt, but negative m dot out will be, if we take negative this side, so we'll get m dot out as minus dm by dt, and it will be equals to greater than or equals to 0. Now we'll be using this equation to find the value of entropy change. So after this we're going to multiply it with dt and integrating the results. So we'll get delta S of surrounding plus m2 times S2 minus m1 times S1 minus S out, and this is m2 minus m1, and it will be greater than or equals to 0. We have all the input data, but we don't have the value of m1 and m2. So we know that m1 will be equals to V divided by V1. V is the volume, and that is given as 20 liter, and if you convert this thing into meter cube, so we'll get 0.02 meter cube. So m1 will be equals to 0.020 meter cube divided by V1 we have obtained as 0. This is 0.01, so 0.01013 meter cube over kg. So after solving this, we'll get the value of m1 as 0.19474 kg, and similarly m2 will be equals to v divided by v2, small v2. So v we have 0.020 meter cube divided by this, the specific volume we have at state 2 is 0.4644 meter cube over kg. So after solving this, we'll get the value of m2 as 0.04307 kg. And one thing more we have to calculate, that is the S out. So S out will be equals to Sg corresponding to pressure 150 kilopascal, and from the same table we'll get the value of this S out as 7.2231 kilojoule over kg Kelvin. Now we can put all the values in this expression, the inequality. So we'll put all the value here. So this is delta S of surrounding that we have to calculate, plus M2 we have this thing 0.04307 kg times S2. So S2 we have this thing 3.7494 kilojoule over kg Kelvin, minus M1 S1. So M1 we have this one 0.19474 kg times S1. So S1 is this one, so 2.0537 kilojoule over kg Kelvin. So now minus S out. So S out is 7.2231 kilojoule over kg Kelvin times M2 minus M1. So M2 is 0.04307 minus M1 we have 0.020, sorry, not this one, 0.19474 meter cube over kg. So after solving this, we'll get the value of delta S of a surrounding will be greater than or equals to minus 0.8708 kilojoule over Kelvin. So this is the final solution. I hope you got the problem. Thank you.